Okay, kids, welcome to this first lesson on triangle inequalities, the first lesson of the unit. What we're going to be doing in this unit, it is separated in two parts. The first part talks about the triangle inequality theorem. So what I'm going to do in this video is that I'm going to talk about that theorem. In the next video, I'm going to talk about the largest side, biggest angle relation. So what we're doing at the beginning of the class is we're asking this question. So imagine that you're a Greek person, like you are in ancient ancient Greece, and you don't have TikTok, you don't have Netflix, and you want to answer this question. The question is, so if I give you three sides, for example, 2, 3, and 4, are those numbers the sides of a triangle? Well, or more in general, like if I give you three quantities at random at all, are those three numbers sides of a triangle? What we try to do in this first exploration, what we do with this table, is answering that question and answering that the answer is not always. For example, here there is an applet, a GeoGebra applet, in which you can go and you can like put the measurement of the sides and check if you can move the vertices around and check if you can actually build a triangle with lines that measure 2, 3, and 4. And well, I invite you to do it. I invite you to try to go to the applet and explore. You will conclude that these three rows, the quantities 2, 5, and 8, 3, 4, and 8, and 4, 5, and 9 won't create a triangle. So the secret of this, the important part of this, is that if you add two sides, those two sides, the addition is smaller than the third side. So I want you to think of it like this. I am not answering the packet. I'm gonna just make this explanation. So imagine that for this quantity, 8, 2, and 5. So I have a segment, the longest segment that measures 8 units. On one endpoint, I stab my compass and I draw a circle of radius 2. So every point in this circle, circle that I did draw horribly, all the points of that circle at a distance of 2 from the endpoint. Now, I am gonna graph my compass again. Staff the other endpoint, and now I'm gonna draw a 5 centimeters of radius circle. So now this circle measures 5 inches or 5 centimeters, 5 units, whatever you want. So these two circles won't ever intersect. And if you see, it's very clear that this distance measures 2 and this distance measures 5. And because adding them together is smaller than 8, actually I can calculate by the segment addition postulate that this measures 1. So these two circles won't intersect. When are these circles intersecting? If the addition would be bigger than 8, then the circles would intersect. For example, in this scenario, the 4, 5, 9, I'm gonna erase this. In the scenario 4, 5, 9, I have a big side of 9. If I draw the circle of 4 inches and the circle of 5 inches, they are tangent, and they are tangent in this point. So these three vertices do not create a triangle. So having two sides should be greater than the other side so that you can create a triangle. I'm gonna write that down. In a triangle, that is a triangle inequality theorem. The sum of the lengths of two sides is greater than the length of the third side. So A plus B is bigger than C, B plus C is bigger than A, and A plus C is bigger than B. This is the triangle inequality theorem. So this is the first big idea of today's class. This video has two big ideas, two important ideas, and this one is the first one. So if I give you three quantities, like for example in the next exercise, for you to check if these three quantities create a triangle, you only need to state the three inequalities and check that the three are true. If the three inequalities are true, then the three numbers are the sides of a triangle. Beautiful. This problem, so from now on, I have finished stating the triangle inequality. Now I'm just gonna apply it into some exercises. There will be a moment in the video in which I'm gonna be stating another important idea. The other big idea of today is here in problem 4. So wait for it. Wait for it. Okay. So this problem is very interesting because it's not only asking us if the numbers create a triangle, they also ask us to classify the triangle given its sides. So, for example, 21, 21, 21. This is an equilateral triangle, no? Well, if it is a triangle, it would be an equilateral triangle. What does equilateral mean? Equilateral means that all three sides are congruent. What does isosceles mean? Isosceles means that two sides are congruent. And scalene means that no side's congruent. That all sides are different. Okay, so for example, I'm gonna go one by one and check each of the cases. 4, 5, 7. So is 4, 5, 7 a triangle? We can check. We just need to state 4 plus 5. Is that bigger than 7? Yes, it is. 5 plus 7, is that bigger than 4? OMG, it is. 5 plus 4, is that bigger than 7? Yes, it is. So this is a triangle, and not only a triangle, but all the sides are different, so that is this type of triangle. In this next one, so for this one, I have to check that 5 plus 8 is bigger than 5. OMG, it is. Awesome. 8 plus 5 is bigger than 5. It's the same. Yes, yes, yes. And then the final one that we have to check is just that 5 plus 5 is bigger than 8, and that also happens. So this is a triangle, and not only a triangle, but an isosceles triangle. So this one is very interesting. So because like if I do 3 plus 5, yes, this is bigger than 2. OMG. If I do 2 plus 5, this is bigger than 3. Awesome. But oh my God, what happens here in 2 plus 5? Sorry, in 2 plus 3, this is exactly 5. So this is wrong because I need this to be greater, not equal. So this is not a triangle, not a triangle. 21, 21, 21 is a triangle. Now it's very easy because 21 plus 21 is bigger than 21. I don't have to write down this 3 times for us to check. And because all the numbers are the same, then we can conclude that this is an equilateral triangle. Awesome. Awesome. Beautiful. Now we are moving for the second big idea of today's video. So this is an important idea. The idea is the following. So I am given that one side measured 10 feet of my triangle and the other side measures 15 feet. So my question is like, what could be like the measurement of the third side? So in this problem, this is a very important problem because I'm going to ask it in several different situations. This is a great application of the triangle inequality. So here it is given two sides. Given two sides, what is better than how? What is the range? What is the range for the third side. It is so weird that I have those B and A and some little marks that I cannot erase. Maybe it's very weird. Look, okay, ignore it. So the range for these two sides, I cannot put any number. Like for example, if I just write, what number would it work? Okay, a 14. 14 does work because 14 plus 10 is bigger than 15. 14 plus 15 is bigger than 10. 10 plus 15 is bigger than 14. So my third side needs to be bigger. My third side, the third side, x, needs to be bigger than 10 plus 15, right? Yes, yes, of course. Sorry, like my brain got bugged. So my third side needs to be smaller than the sum, right? Like my third side x needs to be smaller than 10 plus 15. But it cannot be any small number, no? Like for example, 1. If I just say it like this side should measure 1, it won't work. So it needs to be, what is like the other bound? What is the other bound for the side of this size? And the other bound is like the difference. So x needs to be bigger than 5. So the third side is smaller than the sum, and also the third side is bigger than the difference. Excellent. Okay, so what would be the, okay, so here I am asking for another option for the third side. So any number bigger than 5 and smaller than 25 would be the third side. Excellent. So in these two problems, I am using like the same style of problem, no? So I need to plug in. My question is, which number would not create a triangle? So I need a number that would break the triangle inequality. So for example, I'm just gonna go through the answer because like I don't want to lose your time or my time. I'm just gonna show you like the one that is correct, and that is 5. So if I do 3 times 5 plus 1, that is 16. 5 plus 4, that is 9. And 5 times 5, that is 25. Ay, Mr. Gachoa. 5 times 5 is 25. So, because 16 plus 9 is 25, this is not a triangle. To check the other ones, plug them in and verify for the other 3 inequalities. This is a great problem. The next one is a great problem because here, the problem is shouting at us. The problem is shouting which equation you should be writing. Because look, they are giving us a perimeter and they are giving us the lengths of the sides. So this problem is screaming the following equation. It is screaming x plus 3 plus 3x minus 1 plus 4x equals to 34. And this is a very easy equation to solve. We just need to collect like terms. That would give us 8x. Would you agree? And then plus 2 equals 34. I subtract the 2, so 8x equals to 32, so x equals to 4. Now, again, because they are asking me if these sides could be the measure of a triangle, I need to plug them in. So I have to do 4 plus 3 equals to 7. 3 times 4 minus 1, that is 11, and 4 times 4, that is 16. And these indeed are the sides of a triangle, no? Because you can do 7 plus 11 bigger than 16, 7 plus 16 bigger than 11, 11 plus 16 bigger than 7. So this is a triangle. So yes, it is a triangle. Beautiful. Let us move on for our second to last problem of this first part of the class. Here we have this is a how situation, no? So here, this guy has three boards. One measures 7, the other measures 8, the other measures 16, and now I want to cut one in order to create a triangle. So what should he do? He needs to cut the 16 feet board. And now how? So that it measures less than 15, because the third side of a triangle should be smaller than the sum, but more than 1, no? Because the third side should be bigger than the difference. Now, in this last problem, I am including a beautiful word, such a great word, the word integer. So again, here we're asking how many integer values could the third side of a triangle be? So because I am talking about the third side of a triangle, I know that x should be smaller than 5 plus 8, and x should be bigger than 8 minus 5. So x should be in between 3 and 13. But what does the word integer mean? It means a whole number, a whole number. So which possible values could x be? It could be 4, 5, 6, 7, 8, 9, 10, 11, or 12. Now here it is asking me how many values. So my answer is 9 different values. OMG, let me check. 1, 2, 3, 4, 5, 6, 7, 8, 9 values. This is my final answer. Beautiful. This is the first part of the video. My two big ideas here are, if I give you 3 numbers, you can verify that those 3 numbers are the sides of a triangle by checking the 3 inequalities. And if I give you 2 numbers, the range of the third number is in between the sum and the difference of the first 2. Okay, now we're going to move on to the next topic.